A Bernoulli trial is an experiment that has only two possible outcomes, such as in flipping a coin getting heads or tails, or getting a certain outcome on a die. Roll the die and we want to examine the probability of getting a certain value. The outcomes are assumed to be independent from each other, and so what has happened in the past will not impact what's going to happen in the future. One outcome is referred to as our success, and the other outcome we refer to as the failure, or the opposite of success. The probability of success is denoted by P, and the probability of failure is denoted by Q. Now, since these are the only two possible outcomes that can happen, their sum is equal to 1. The sum of the probability P and Q is equal to 1. A random variable x is used to count the number of successes in a sequence of n independent Bernoulli trials. This random variable is called a binomial random variable because, once again, when you conduct your experiment, there are only two things that can happen. Either you get your desired result or you do not. The values that x can take on start at 0. That would mean that we have no successes, all the way up until n. N is the maximum number of successes that you could have. That would be the same as the number of trials in your experiment. The probability of exactly x successes in a sequence of n independent trials is found by calculating the combination of n choosing x, so it's a combination out of n trials, we choose x to be successful, times the probability of success to that number of success power, times the probability of failure to the number of failures power. If you have x successes, that means the remaining outcomes would be represented as failures. That's where n minus x comes into play. So n is the total number of trials, x is the number of successes that we are aiming towards, p is the probability of success, and q is the probability of failure. In example 1, Joe likes to play darts. On any given throw, his probability of getting a bullseye hit is 1 out of 3. That means that the probability he does not hit the bullseye would be 2 out of 3. If Joe throws 8 darts, what is the probability he will get exactly 3 bullseyes? The number of trials in this case is 8. The probability of success is 1/3. We're going to define a success in this example to represent hitting the bullseye. Therefore, the failure would be not hitting the bullseye. Once again, we have a total of 8 trials because he's throwing 8 darts. The probability of success is 1 out of 3. The probability of failure is 2 out of 3. And the question wants you to find the probability he gets exactly 3 bullseyes. So according to the formula that's above, we want to do a combination of 8 trials. We will choose 3 of them to be successful. The probability of success is 1/3. We want that to happen 3 times. Times the probability of failure, which is where he does not hit the bullseye. And that will happen 8 minus 3, or just 5 times. So he throws the darts 8 times. We want to find the chances that he gets 3 hits and 5 misses. When we work this out, we get a probability equal to 0.2731. Therefore, we'll say that if he throws the darts 8 times, there is a 0.2731 chance, or about a 27% chance, that he will hit exactly 3 bullseyes. Suppose a basketball player makes 82% of her free throw shots. Assume that each time she shoots a free throw is independent of her previous attempts. While at practice one day, she shoots 4 free throws. Describe the random variable, which is binomial x, in this situation. Then we're going to list all the possible values of x and give the values of p and q. Those are your probabilities. So in this case, my random variable x is going to count how many free throws she makes. X can take on the values 0, 1, 2, 3, or 4, because that's the number of shots she's going to attempt. The probability of success, in this case success would be making a free throw. The probability that that happens is 0.82, because she makes 82% of her free throws, and the probability she misses this shot is 0.18, because they have to add up to 1. Next, we're going to construct a probability distribution table. We remember from before, this would be a table that shows all of our possible outcomes, those are the values of X, and each of their probabilities. X can be any value, 0, 1, 2, 3, or 4. To find the probability of each of these values, I'm going to use the formula I learned about on the first page. The number of trials is 4, because that's the number of shots she's going to attempt. To find the probability that she makes none of her shots, that means that all of her shots were missed. We use the formula to say that out of 4 shots, we choose 0 to be our success. The probability of success is 82, but it doesn't matter because she won't make any. The probability of failure is 0.18, and if she makes 0 shots, that means she had missed all of them. So 0.18 is raised to the 4th power. We'll find the probability that she makes exactly 1 shot. Now, we don't care if this is her first shot or her last shot or somewhere in between. Out of the 4 attempts that she tries, we want to choose one of them to be successful. That one successful shot has an 82% chance of occurring. And once again, that happens just one time. The probability she will miss is 0.18. And she will be missing 3 times because she only makes 1 shot. Therefore, she misses 3. We're going to continue this all the way down using the formula each time. Then you're going to use your calculators to figure out each of these probabilities. Once you have calculated each of these probabilities, check with what you see on the screen now to make sure you haven't made any mistakes. You could also check your answers to make sure that they add up to 1. The sum is equal to 1. We're going to use this probability distribution table to draw or sketch a probability histogram. We learned about histograms in the last section. So the x-axis stands for the value of our random variable, and the y-axis stands for its probability. The bar that you draw for each of your values of x is going to be centered above that particular value for x, which means the bar that goes for the x value of 0 is going to be directly on the y-axis. It only has a probability of 0.001, so it doesn't go up very high. In fact, what I've done right now is I've exaggerated the height of this bar, just so that we could see it. The next bar is slightly higher, but still it's going to be exaggerated on your paper. The bar above 2 goes up to 0.13. The bar above 3 goes to almost 0.4. And the bar above 4 goes to 0.45. This is what we're going to see now for our probability histogram. Notice that towards the end of my histogram, where the values of x are larger, the bars are much taller. They have a higher probability of occurring. And this makes sense when you understand what the bars represent. Since the probability of success is so high, it's closer to 1 than it is to 0. Therefore, we would expect to have more successes than failures. Once again, the probability of success is 0.82. We would expect most of the time to be successful. That would represent high x values. So this is going to be the shape of your graph whenever your probability value is large. If it's closer to 1 than it is to 0, we would expect to have taller bars for larger values of x and the shorter bars for small values of x, because we expect to see success happen more often than failure. We're going to use our probabilities that we've computed to answer the questions that follow. What is the probability that she will make all 4 of her shots? This means to find the probability that x equals 4. According to your calculations in your table, this probability is 0.4521. This is the same as the area of this last rectangle that is above 4. That rectangle has a width of 1 unit. It goes from 3.5 to 4.5. And the height of that rectangle or bar is the same as what its probability was that we calculated. So the probability that x equals 4 is the same as the area of the bar above 4. What is the probability that she will make exactly 2 of her 4 free throws? That means that x equals 2 is your probability that you're calculating. This is the same as the area of the bar above the value 2. According to your table, this probability was found to be 0.1307. The last question says, what is the probability she will make at least 1 of her 4 free throws? That means that x is greater than or equal to 1. At least 1 means 1 or more. You could go to your table and add all the probabilities together where x equals 1, x equals 2, x equals 3, and x equals 4. That would give you your answer. However, we're going to do the opposite of what this question wants us to find. We are going to find the probability that she makes none of her free throws. And we're going to subtract that answer from 1. And this is what we get for our solution. So she has a pretty decent chance of making at least 1 of her shots out of 4, almost 100% of the time. The next example is a test that consists of 3 multiple choice questions. Each question has 5 possible responses, which means A, B, C, D, or E is what you're choosing from for your answer. Suppose that a person guesses when answering all of the questions. And we also assume that none of the questions are left blank. Describe the binomial variable x for this situation. In this case, we're going to define our success as getting the correct answer. Now the binomial random variable x is going to count how many questions she got correct. If this person is taking the test that involves 3 questions in this part, it is possible that the person gets 0 questions correct, or they could get 1 question correct, or 2, or all 3 correct. So because the success is getting the correct answer, and out of that list of 5 options, A, B, C, D, and E, only one of those is the right answer, the probability of getting the right answer is 1 out of 5, or you can write this as 0.2. The probability that she does not get the question correct is 4 chances out of 5, or you could write this as 0.8. Next, we're going to draw our probability distribution table, which is going to list all of the values of x and each of their individual probabilities. The values of x could be 0, 1, 2, or 3. The probability of getting 0 answers correct is found by finding the combination of 3 questions, choosing 0. Your number of questions is the number of trials, which is n. Out of the 3 questions, we're going to choose 0 to get correct. The probability of getting a right answer is 0.2, but it doesn't matter because we're not going to get any right answers. The probability of getting the answer wrong is 0.8, and that's going to happen for all 3 questions. To find the probability that the student gets exactly 1 question correct, out of the 3 questions that are being answered, we're going to choose one of those to be the correct answer. The probability that that correct answer was obtained is 0.2, and that only happens 1 time. The probability of missing the question is 0.8, and that will happen 2 times. Or what if the student gets 2 questions correct? The probability that this will happen is a combination of 3 choose 2 times the probability of getting it correct, that happens twice, times the probability of failure, that happens once. And finally, combination of 3 choose 3, which means she gets all the questions correct. The probability for each question being marked correct is 0.2. That will be raised to the 3rd power since that happens 3 times. And then she misses the questions 80% of the time, and that will not happen at all because all 3 questions were answered correctly. Now you're going to use your calculator to figure out each of these quantities. And those are your answers. You could check to make sure you had everything represented by adding them up, and you should see that the sum is equal to 1. We're going to take this table of probabilities and we're going to sketch a probability histogram to show the shape of our distribution of x. X stands for how many questions were marked correctly, and the y variable is your probability that this happens. The probability of getting 0 questions correct has the highest probability at 0.512. The probability of getting exactly 1 question correct is almost 0.4. The probability of 2 questions marked correct is 0.096. And the probability that all 3 are correct is only 0.008. Remember, she's not reading the questions, she's just simply answering randomly, choosing a letter randomly. The chances of the student getting all questions correct if she makes random guesses is only 0.008. In this case, we would expect to have more failures than successes, since the probability of success is closer to 0 than it is to 1. In other words, we would expect to see more values of x that are on the lower end. Because we would expect to see failures happen more often than successes. Find the probability of getting exactly 2 questions correct. That would be the area of the bar that is above the x value 2. In your table, you computed this answer to be 0.096. Find the probability of guessing at most 2 of the questions correctly. At most 2 questions correct means 2 is the most. Can't go any higher than 2. You have to stay less than or equal to 2. This is found by adding up the probabilities where x is equal to 0, plus 1, plus 2. But instead of adding those 3 numbers together, I'm going to subtract the one answer I'm leaving out from the total 1. So I'm going to subtract 0.008 from 1. And the probability she gets at most 2 questions correct is 0.992. Example 4. The most common blood type in the U.S. is O positive, with 38% of the population having this blood type. You select 10 of your classmates at random. What is the probability that exactly 4 or exactly 5 of them will have blood type O positive? It's important to understand what a success is in each of these problems. A success in this case is choosing somebody with blood type O. And therefore, the probability of this success is 0.38. The probability we do not choose a person with blood type O positive is 1 minus 0.38, or 0.62. It says you select 10 of your classmates. That's the number of independent trials. Each person's blood type is independent of the others. What is the probability that exactly 4 or exactly 5 have blood type O positive? We will compute these separately and then we will add our answers together. For exactly 4 successes, out of your 10 classmates, you are going to choose 4 to be classified as success. The probability of success is 0.38, and this happens 4 times, so we raise it to the 4th power. The probability we do not have a success is 0.62, and this will happen for 6 people. Or we could have exactly 5 successes. Combination of 10 choose 5 times 0.38 to the 5th times 0.62 to the 5th. Altogether, we get 0.4316 for the probability of having exactly 4 or exactly 5 successes in a sequence of 10 trials. We did not calculate the probabilities of all possible values for x. X could take on values anywhere from 0 all the way to 10, because that was your value of n. If you drew a probability distribution table, you would have to compute the probabilities of all 11 of these outcomes. Then, to draw a probability histogram, you would need to draw a histogram with 11 bars, 11 rectangles. We're not going to do all that work right now, but I do want to ask, what is the shape that you anticipate seeing in your histogram? Do you anticipate seeing tall bars in the beginning or tall bars in the end? Now remember, your probability of success is 0.38. That number is closer to 0 than it is to 1. I expect to see more failures than I do successes. X is measuring or counting the number of successes. If I expect to see more failures, that means I expect taller bars in the beginning. And then as my value of X increases, I expect the bars to get shorter because I don't think this is going to happen quite as often as the smaller values of X did. So this is the general shape that your histogram would have because, once again, that probability of success is closer to 0 than it is to 1. Therefore, we expect more failures. And if I expect more failures, that means I expect fewer successes. So the number of successes that I expect to see is going to be higher at the lower end than it is at the upper end. All right, this takes care of section 8.2. Log into WebAssign, get your homework done.